Hello everyone and welcome to another Tech Talk session by BCS Electronics. The purpose and goal of this tutorial is to show how you can save time, increase quality, and spend valuable engineering time on the application instead of configuration. To do so, we provide a powerful concept we call device configuration. This is a feature in our development platform BCS Tools. This is the system layout. The task of today is to create a configuration between the HMI with built-in control and the frequency inverters. Communication between the HMI and inverters will be using EtherCAT as field bus. EtherCAT provides a fast and deterministic update of the running process, combined with great diagnostic capabilities. Let's take a look more in detail of the different components in use. For configuration and programming development platform BCS Tools. For visualization and control, X2 control. Frequency inverter BFI, P2 or BFI, H3 with EtherCAT option. Unmanaged switch JetNet 2205 for connectivity between BCS Tools and X2 control. To download BCS Tools, browse to BCS Electronics Smart Store using the link provided in this slide. If this is the first time you need to register an account, once made you'll receive an auto reply with information about the activation of the account. This is the landing page after a successful login and where you'll find a direct link to the latest version of BCS Tools. By the way, BCS Tools is free of charge and requires no license. Preparations of X2 control. Connect the power terminals to the power source and power on the HMI. There are two LAN ports available, LAN A and LAN B. When using EtherCAT, LAN A is the dedicated port for communication. LAN B will be used for all IP-based communications such as communication between BCS Tools and X2 control. At delivery, the HMI will display a welcome screen after the boot process. Press anywhere on the screen to enter the service menu and set the IP address for LAN B accordingly. These steps are considered to be self-instructed and will not be covered in this tutorial. For details about the service menu, please visit https://www.bceselectronics.com/docs. Preparations of frequency inverter BFI, P2/H3. Connect the power and motor cables according to the installation instructions of the user's manual. The inverter has a safe torque-off input, and in this example we will bypass this input according to the following scheme. For EtherCAT communication, a communication board is needed, the ABCCTC. The inverter has a specific slot to expand its communication capabilities, the amount of I/O/S or to connect encoders. Remove the front and insert the communication board in the slot de-energized on the inverter and set the following parameters to enable field bus control. The P1-14 is to enable access to all parameters groups available, no just the basic ones. For further details, refer to the BFI product section on our homepage. There is no need for any specific preparations for JetNet 2025. Wire the PWR terminals to a 24 VDC power source and appropriate grounding. Connect the network cabling to the PC running BCS Tools and X2 control. Preparations of the EtherCAT network. Use LAN A in X2 control and connect it to port IN on the first inverter. To connect the second inverter, connect the cable from the out port of the first inverter to the IN port of the second. When using high-speed Ethernet-based protocols, a proper installation is a crucial part, and we recommend to follow guidelines from the EtherCAT organization. Use the link above to go to the website for downloads. Preparations of the IP network. Use LAN B in X2 control and connect it to any of the available ports in JetNet 2205. Connect the computer with BCS Tools to the same switch and make sure the IP address of X2 control and the PC is on the same subnet. An example is shown in this slide. Moving forward with project creation according to the following schematics. Start by creating a new project. To apply filter on the available devices, set the device category to HMI and subcategory to X2 control. The device model in use is the 4-inch screen in power failed mode. At delivery, X2 control HMIs are configured as power failed, meaning the persistent variables will be saved at the power interruption. The other mode, cyclic, requires a reinstallation of the control runtime. Cyclic mode will expand the amount of persistent variables. However, it might have an influence in decreased performance and will not save the variables before power loss. For backwards compatibility, there is support for older runtime systems also. Next step is to select Field Bus. This view will show the available communication ports combined with the available field bus drivers of each port. LAN A is the dedicated port when using EtherCAT. BCS Tools is preloaded with our available slave devices and field buses. In this example, we will select two frequency inverters, the BFI 1.09. The last step is a selection of programming language for the basic project structure and can be changed afterwards. This selection will not have any impact of other POUs inside the project. BCS Tools will now create the necessary components. The project is built as a tree structure starting with a project name, followed by the device, application, and the subparts beneath the application. Based on the selections from the wizard, BCS Tools has created a complete field bus configuration, connected to the correct Ethernet port with the correct library versions based on the runtime system. The GVL_HMI is a pre-made variable list intended to be used with variables for data exchange between HMI and controller. This list has an attribute which will expose all variables for external communication via the symbol configuration object. The symbol configuration object is where variables are selected for external communication. The persistent vars object is a list where persistent variables are declared. These will keep their values after a recycle of power. The library manager has a collection of libraries used by this specific application. As in this example, when using the inverters, the associated libraries has been inserted by BCS Tools. The folders, System GVLs and System POUs contains the necessary variables and code to control the inverters. Inside the System GVLs there is the BFI definitions list which contains the structures for each drive. The BFIMI, which contains the variables for manual override. The System POUs contains the BFI EtherCAT PRG and BFI HMI PRG. The BFI handles the manual override function. The PO BFI EtherCPRG contains the function blocks inserted by BCS Tools. The function block handle functions like start/stop, set frequency, read/write of parameters, inverter information, alarming, manual override, and more. To add or remove slave devices, use the right-click mouse button command in the product tree. When a slave is removed, all associated components in the project are removed by the device configurator. Adding a slave will insert all associated components. When inserting devices, BCS Tools uses a default name with the addition of a sequential number, as in this case BFI_EtherCAT_1 and BFI_EtherCAT_2. Based on this name, the structure created in BFI definitions uses the slave name and adds the underscore drive as an extension. This name is then used for the function block and the I/O mapping for the slave. To use another variable name, there are different approaches. The most convenient is to rename the slave in the project tree. This will trigger the refactoring function and the old name will be replaced in the entire project. The other option is to use your own declaration and connect it to the auto-generated variable. By using the data type reference to and initialization, you can create a relationship between the user-defined and the auto-generated variable. The structure to be used is located in the sublibrary named BFI base. Start by inserting a new GVL. Enter the variable name, reference to, and the data type. Use the variable created by the Device Configurator and connect it to the initialization option. The variable can now be used in the same way as others and is linked to the auto-generated variable. Here is an example. If the auto-generation function is not wanted or needed, there is an option to disable it. This setting is available in Tools/Options/Device Configurator. Use the checkbox to enable/disable the function. Confirm the new setting with the OK button. When inserting a new slave device, no components will be generated. Double-click the device in the project tree and open the Communication Settings dialog. Scan the network or manually type in the IP address. Click the Login button to download the application. When download is complete, set the application to run. Green icons should now appear next to the slave devices in the product tree. Open up the POU with the function blocks. They will now show the online status of all the inputs and outputs. Important signals to look at are OK, which will be set to true if communication is online. Communication state, which will show the current communication state according to the EtherCAT state machine. Drive info, which contains the drive model, type, and serial number. To test operation from BCS Tools, we will now prepare a set frequency and then enable the start signal. To activate the prepared values, go to Debug and select Write Values or use the shortcut Ctrl plus F7. If all went well, the run variable will be true and the output frequency will be seen. To stop the drive, prepare the value false to the start signal and write the value. The inverter will decelerate, and when it has stopped, the run signal turns to false. To provide an easy way to control the drives, there is a template project available for iX Developer which corresponds with the code the Device Configurator generates. To use the project, the necessary adjustment is the configured IP address on LAN B. Click on the tags icon, the tab controller, select the controller 1 and press Settings. Select the Stations tab and change to the IP address in use. All necessary variables for the HMI connection has already been prepared and published by BCS Tools. For our convenience, we will use the online simulator which will communicate directly from the computer to the controller. Press the green Run icon to start the application. The startup screen will show the type of connected controller. This is the overview page. From here we maneuver the inverter. The page is indexed, meaning that we can control any number of inverters with no programming effort. All features provided by the function blocks are available here in the HMI application. To switch between the inverters, use the left/right buttons in the top left corner. To read or write parameters, use the buttons or make a direct input. The syntax follows the actual parameter number in the inverter, like in this case the rated voltage for the motor P107. Press and hold the read or write button to perform the action. To run the inverter in manual mode, click the button Run BFI from this menu. This mode will override the input signals from the function blocks. Set the frequency and press Start/Stop. The status bar above will show the current status. This is a demonstration of the alarm function and how to acknowledge the alarm. The analog input of the inverter is set to 4 to 20 mA signal, which causes a trip action. Thank you for watching.